This is a demo of the design and implementation of a three-tier web application using AWS Cloud. The network is located in one region with two availability zones. It is divided into different layers. The first layer is public subnet. Next layer will be the first tier, which is the web tier. Second tier is application tier, and then the database tier. This modularized the application in such a way that each part can be managed independently. Instances in each tier is created in both availability zone to address the high availability requirements. Each tier is encapsulated in security groups as firewall to control the flow of traffic. The application is horizontally scalable, and to do this, I've used one external load balancer and internal load balancer. Accessing the web server is only through web load balancer, while the application server is accessible only through web tier via private IP. Both load balancer is encapsulated in security groups as well. Database tier is accessible only through app tier via private IP. As part of scalability feature, I've used auto-scaling group, which uses 2 AMI. This monitors the applications and automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. On the AWS Management Console, I set up the virtual private VPC. Named as Project VPC. Then I've created the internet gateways. Then I've created the 8 subnets as per the design. Next, I've created the 2 NAT gateways. The NAT gateway enables the EC2 instances in the private subnet to access the internet. Both uses the public subnet. I've created the route tables. The route table is a set of rules that determines how data moves within network. I've created 3 route tables and associated them with corresponding subnets and set up the correct route. Then I've created all the required security groups. First is the Web ELB security group that allow access to the web via load balancer. Then the web security group allow access to the HTTP from the web ELB security group. Then the app ELB security group, which allow access to the app ELB from the web tier. And then the app security group, which allow access to HTTP from the app ELB. The database security group allow access to MySQL from the app tier. And for testing purposes, web server and app server, I've created temporarily a security group called config security group to allow access to EC2 to test via internet browser. I've created first the 2 EC2 instances that uses this config SG. The web config server and app config server both has public subnet and enable public IP address. Later on, these two instances will be used for creating the AMI, which will be utilized when creating the auto-scaling, specifically on the launch configuration. On the final layout, these two instances can be removed. To test the instances, copy the public IPv4 and open it to another tab. After confirming that it works, I proceed to create the AMI out of this server. Selecting each server and using the action menu, I've created the image, and the AMI can be viewed in the AMI page, which I've created to AMI. The web AMI and the app AMI. Then I've created the RTS database, which is the MySQL database. First, I've created the subnet groups as required for the database, which I call it Project DB subnet group that uses database private IPv4 address in both Zone 1 and Zone 2, respectively. Then I've created a database called Project DB instance, a free tier, MySQL, and it uses the database security group. And to test the database, I changed the database security group to allow access to config SG instead of app security group. I edited the inbound and changed it temporarily to config SG. Then on the web ELB or web config server, I can test the database. That confirms that the database works. Then I put back the original setting of the database security group. After creating the database, I've created the load balancer. I've created two application load balancer using internet facing as scheme, the web ELB and app ELB. On creating the load balancer, I've also created the target groups for each load balancer, the web group and the app group. On the final steps, I've created the launch configuration and auto-scaling group. The launch config uses P2 micro and the corresponding AMI that I've created previously. And I've used the existing key pair, Voc key. From the launch configuration, I've created the auto-scaling group and attached each auto-scaling group to corresponding load balancer. To test the application now, check that the two instances of our auto-scaling group for each web and app is created. This shows that the auto-scaling group, which has a desired capacity of 2, minimum of 2, and maximum of 4, is working. The web auto-scale and the app auto-scale. And to test our application, we can check it by selecting the web auto-scale, the web load balancer. And from the load balancer, select the web ELB and copy the DNS name. And on a different tab, paste it and check if it is accessible. Our application is accessible via web ELB, and that concludes the 3-tier application implementation using the AWS Cloud. Thank you.